right, so if we just have a quick look at some important things that we need to remember as we start to have this conversation about equations is, firstly, please remember your inverse operations when you solve equations. And secondly, now that we start introducing distribution, English, what is really, really important is that we remember we have to distribute, or we have to do the distribution first, and then we start using our inverse operations, right? So whenever you see brackets, so distribution, we need to deal with that first. So we need to simplify everything that we have going on so that we can properly solve our equation. Okay, so let's have a look at some examples. And here we've got example 1 where we've got 2 times x minus 1 plus 4. So based on what I have just said, the very, very first thing that we do is we deal with this distribution. Now, grade 8s, remember, distribution implies or is a multiplication operation. So that means I need to take this 2 and I need to multiply it with the x, and I need to multiply it with the negative 1. Now, guys, obviously, if you're comfortable, you don't have to do your working out on the side. You can just go straight to an answer. But just to make sure we're all happy, 2 times x, positive times a positive is a positive, and 2 times x gives us 2x. We then have 2 times negative 1. A positive times a negative is a negative. 2 times 1 is 2. So through distribution, we are getting rid of those brackets, and we have got 2x minus 2 is equal to 4. Only once we have completed that distribution do we now solve using our inverse operations. Remember, inverse operations is another way we can say that rather is to use the opposite operation. We solve our equation doing the opposite of what we originally had. Just a very quick side note, because I don't know if I explained this last time, or if teacher Jen explained it in her lesson that she had with you last week, Monday. These three dots over there, so the 3 dots in a triangle, they mean therefore. So they mean therefore. Basically, we use them whenever we are dealing with equations. You can actually use them when you're dealing with expressions as well, but we use them because we cannot have 2 equal signs on the line. So we just use the 3 little dots for therefore for each new step to say, therefore, I've distributed, now I can do the next thing. Therefore, I've used my inverse operation, now I can do the next thing. So that's what those 3 little dots mean, just so we all know, and we use them to indicate that we're moving on to our next step. Right, but back to solving our equation. Remember, the goal is that we want to get x alone. That is what solving an equation means. The instruction even says solve for x. So we need to get rid of this minus 2 and this times 2. And this is now where our inverse operations become important. Remember, what we've always said, or what I have said, is that when you solve an equation, this involves getting your x terms to one side or your variable terms to one side. I always put mine on the left. It doesn't actually matter what side you put them on, but I always put them to the left just so that it's always x equals. So we get our variables to one side, and then we get our numbers or our constants to the other side. So if I have a look at what I've got here, I've already got my x term on the left-hand side. So I'm fine with 2x being on the left. What I don't like in this equation is this minus 2 that I have here. So I want to take this minus 2 and I essentially want to bring it over the equal sign so that it can join the other constant on the right. But the second I move anything over the equal sign, the second I start moving terms, I need to remember that the sign or the operation needs to be the opposite. The inverse operations need to apply. And so what that means is I actually need to add 2 in order to bring that minus 2 over. What we then end up with is the 2x alone on the left-hand side, which is what I want. And then on the right-hand side, 4 plus 2 on the right. All my constants are now on the right. I can neaten up that right-hand side because we know that 4 plus 2 is 6. And then once again, I need to use my inverse operations to solve for x. Now, grade 8s again, what you need to remember is that between the 2 and the x, there is a multiplication. So if I want to get rid of that 2, I have to use the inverse operation. And so what I need to do is I need to divide both sides by 2. Okay, grade 8s, you need to be focusing on what I'm saying. I'm literally explaining a new concept to you. Please, on the chat, if you are chatting and you're just going on and on and on, you are not focused on what I'm saying, and it means that I'm going to get questions that I should not be getting. Stop on the chat, listen to what I'm saying, and then we will deal with any issues that you have. You know how this works. Please.
Yes, my people, we listen first and then we can ask later, remember? So Valga, I see your hand, but it's not time for hands yet. So I keep on lowering your hand. All that you have to do is to be observant. You might have an idea on how we're actually doing this, but please listen, everyone. We are listening to Teacher Sam. When she's done, she will give you a chance to ask your question or to have your query. And sometimes even you will do a question like this by yourself, okay? But now we are all listening, my people. Let's do that. Let's do the listening part. That's all we are doing now, okay? And take notes if you have to. Screenshot, whether you are writing down, doesn't matter, but pay attention, my people. But good people, let's do this.
Right, so 2 times x, we need to get rid of that 2, so we use the inverse operation, which is division. Now, you cannot only divide on the left-hand side, or you cannot only divide one term. If you're going to divide one term, you have to divide everything, which means that we also need to divide the 6 by 2. Now, guys, we know that 2 divided by 2 is 1. So essentially what's happening on the left is that coefficient is being cancelled, and all we are left with is this x. We are solving for x. We are getting x alone. I simplify the right. 6 divided by 2 is 3. And so I have solved for x. Now, remember, we can check our answer if we're not 100% sure, if we want to make sure that we have done it correctly. You do not need to show this check unless you are asked to do so in a question. So this is something you do quickly, roughly on the side of your page or quickly with your calculator. We use substitution. So in place of x, I'm going to put 3. So 2 times 3 minus 1 should give me 4. And the whole point of your check is to make sure that the left-hand side is equal to the right-hand side. So in my brackets, 2 minus 3 is 2. So I've got 2 times 2 equals 4. And we know that 2 times 2 is 4. And so because my left-hand side is equal to my right-hand side, I know that this value or this answer of x equals 3 is correct. I know that I've done it properly and I've got the correct value for x. So when you are solving an equation that involves distribution, as I said, the very first thing that you do is you distribute, and then you start to use those inverse operations that we spent last week dealing with. When you're solving an equation, always try to get your variables to one side. I always get mine to the left, but it doesn't matter. And then your constants or your numbers by themselves on the other side of your equal sign. And then you go and solve for x using your inverse operations. Right, so take your screenshots. Now is the time that if you have a question, you may raise your hand and I will answer your question. And so hopefully any issues will be dealt with. Logan?
Okay, Miss. So can you tell me now, like, how did you get the answer to 4?
What do you mean the answer to 4? Which part?
Yeah, but in the purple block, left-hand side is equal to the right-hand side.
Okay, so what I did in the purple block was I took my answer for x and I substituted it into the original equation, because remember, this was 2 times x minus 1 equals 4. So I replaced the x with a 3.
So in the between the x and 2, is there like a multiply?
Exactly. There's multiplication. So if we go back up to the original question, in between this 2 and the bracket, there's a multiplication. This is why, if you look in this orange block here, we are multiplying the 2. We're distributing the 2 to both the x and the -1.
Okay.
Okay, good.
Like in our class, like we do it like the left hand side is equal to the right hand side. But if we get on the right hand side is equal to the left hand side.
Yeah, so that's the point of an equation. So an equation should be that the left is equal to the right, or the left has the same value as the right. So that's
So
why we, yeah.
Will it come in the test, like make example, like for exams time, can you like write it the way like you did it, Miss also?
Yeah, that's fine.
Okay, thank you, Miss. Can go on.
Oh gosh, there's so much going on here. Sambiso?
Yes, ma'am.
Question?
Yes, ma'am. I wanted to ask, what if the variable is an exponent? Does it still apply the same rule? Or is it too early to ask?
So no, I'm just, so if your variable is an exponent, I'm just trying to think if I just want to make sure I haven't actually spoken about this before. I'm like losing my mind. No, all right. So if your variable is exponent, the idea of inverse operations is still the same. So we still need to apply like everything that we've learned with equations. When your unknown or when your variable is an exponent, we do have to think about things a little bit differently, and we have to start, or we have to remember to apply our exponent laws. But we will deal with exponential or equations with exponents and see how we deal with them. You do it a little bit differently, but like the general idea is still that we want the left-hand side equal to the right-hand side.
Ma'am, correct me if I'm wrong, but I think don't you use you change the constant into exponents, like for 4 equals
Excuse me, you change a
4.
what?
If you change your constant into exponents, for example, 2x minus 1 equals to 4, the 4 will be 2 exponents 2.
Yeah, so that's what I was saying. We do a little bit differently, and we have to apply our exponent laws, but we will chat about those when we get there.
Yes, ma'am. Thank you.
Okay, so grade 8, I hope you've all got screenshots. I'm moving on to the next question. Please can I also remind everyone that questions and comments and messages on the chat, whether it's to myself or Yolanda, are focused on the lesson. We're not dealing with anything else right now, and the same goes for any questions in general, right? If your question is not based on the question we're doing, I don't want to know. Right, so if we have a look here at question 2, we still have distribution, but we just need to bear in mind now that we've got distribution on both sides of our equal sign. Doesn't change what we do it exactly the same, but we do need to deal with this distribution. So the first thing that we're going to do, as I've already said to you, is that we distribute, or we multiply, because as Vogan said, there's a times between the 2 and the bracket. Grade 8s. I must be honest, I will just end this lesson, because if you are just going to waste my time, and you're going to waste Yolanda's time, and you're going to waste everyone else's time, I'm not doing this. I'm not sitting here for another half an hour with you for you to just not participate, not actually care.
Yes, guys, because we can see all the messages, right? So you are not allowed either way to send each other messages. So let's focus on what's on the board and let's learn. And that's all that we are doing, right, my people? Because we love you, all of you. But then if we see anyone just misbehaving, then we will put you on the waiting room. Okay. So now you won't hear any warnings from us. I will definitely just focus on putting you on the waiting room, and then you can wait there, think a little bit, and then come back to class. Okay. Let's focus, my people. Let's do this.
Right,
Sorry,
so we're
sister.
distributing. No, it's thank you. Because I'm in no sort of mood today. I will end this lesson right now. I'm not fighting with children. All right, so guys, we distribute. That means that, like I say, as Vogan told us, this is multiplication and we need to do it properly. All right, so I'm going to set up two little working out blocks here for myself so that I can do the distribution on each side. So this first block is going to look at the distribution of 2 times x plus 2, and the second 3 times 2x minus 1. So firstly, I need to multiply the 2 with the x and the 2 with the 2 on the left-hand side. Now we've done something very similar. 2 times x is 2x, and 2 times positive 2 is positive 4. So on the left-hand side, I have simplified this to 2x plus 4. And now on the right-hand side, I'm going to do the same thing. I'm going to distribute. So I've got 3 times 2x and 3 times negative 1. 3 times 2 gives us 6, and then we've still got that x. So 3 times 2x is 6x. Be careful here. You're saying 3 times negative 1. A positive times a negative is a negative. And so we've got negative 3, which means on the right-hand side of my equation, I have got 6x minus 3. Now this goes back to what I said here in step 2. We now solve our equation, but very, very importantly is we now need to understand, or we need to remember, that I'm going to have to get my variables to one side and my constants to the other side. So if I look at question 2, I can see that I've got a variable term on the left and the right, and a constant term on the left and the right. Now I'm going to say it again. It does not matter which side you choose to put your x's and which side you choose to put your numbers. It doesn't matter. As long as you correctly apply your inverse operations, you will get exactly the same answer. Like I say, I always put my x's on the left because I like my answer to say x equals, and we read our answer from left to right. So what I'm going to do is I'm going to take the 6x and bring it over to the left-hand side. It was positive 6x, which means that now that I'm moving it, it's going to become minus 6x. It is going to become the inverse or the opposite operation. In a very similar way, the positive 4 needs to now join the negative 3 on the right-hand side. But the second I move it over the equal sign, it's now going to become negative 4. On the left-hand side, I now have 2x minus 6, because remember, I brought that positive 6 over the equal sign. And on the right-hand side, this negative 3 is still there. But now I also have minus 4 because I'm bringing the positive 4 over to the right-hand side. All right, I now neaten up each side. 2x minus 6x, remember, like terms. So I've got minus 4x. Minus 3 minus 4 gives me negative 7. Now you still, sorry if you can hear all this raving outside, you still need to solve for x. So what I don't like, or what I need to deal with, is this negative 4. Now remember, this is saying negative 4 times x. So I need to use my inverse operations, which means I need to divide by negative 4. Negative 4 divided by negative 4 just cancels. It gives us 1. But if I'm going to do that on the left-hand side, I also have to do it on the right-hand side. So that now means on the left, I just have my x, which is what I want. And now we can simplify the right. Now, guys, remember, negative divided by negative is a positive. And 7 divided by 4, I can't actually simplify any further. So it is just 7 over 4. Now, you can write this answer in different forms. You could write it as a mixed number. You could write it as a decimal. We prefer you to just leave it as an improper fraction. So this 7 over 4, leave it like that. As long as it's simplified, you are fine. If, however, you don't want to leave it like that, like I say, it's not the end of the world, but we prefer improper. a mixed number, or as a mixed number, this is 1 3/4. As a decimal, it is 1,75. Like I said, again, we prefer improper fractions. And as you move up in the grades, improper fractions is much better, but it's not wrong to write it as 1 3/4 or 1,75. So once again, whenever there's distribution, you need to deal with the distribution first. Once you have distributed, you get all your x terms to one side and your constants to the other side. And then you start to solve your equation using your inverse operations. Take your screenshots. If you have questions, now is the time to raise your hand and ask. Sadie?
Hello, ma'am.
Hello?
Ma'am, I have a question. Is it a must to minus and add your like terms?
Yes, because they're like terms. So to simplify and to solve for x, we need to get one x term. So we would have to add and subtract them, yes.
Okay, ma'am. Thank you, ma'am.
Okay. Bogan?
Mas,
Yes.
so how did you make it -4 turn into a -4 if it was a positive?
Because remember, when we bring it over the equal sign, the sign has to change. So because it was +4 on the left, when I move it to the right, it becomes -4.
Okay, and that
That's
-4 x equal to -7, I take it to -7.
So remember, -3 minus another 4. So I'm over here. If I'm already at -3 and I take away another 4, I end up with -7.
Okay,
Okay,
okay, thank you, ma'am.
good. Nelisa?
Hi, ma'am.
Hi.
Ma'am, so whenever you are working with exponents, you always have to minus them.
Okay, so I'm not working with any exponents here. So which part are you talking about?
Ma'am, with the first line with the purple and pink lines there.
Okay, so sorry, those aren't exponents. What I'm trying to show you is that what we want is we want to take this 6x and we want to essentially move it to the left-hand side. If you do that, you then have to subtract it because it was +6. If you bring it over, it becomes -6. The same thing with the 4. I want to take this 4 and I want to move it to the right-hand side. And because it was +4, I now need to subtract 4 in order to bring it over.
Okay, thank you, ma'am.
Sorry, guys. Yeah, those aren't exponents. I'm sorry if that's a bit confusing. I'll try and draw it better as we go along. Sibonga?
Ma'am, can I ask something? Say by
Yeah.
your first step, we wrote 2x plus 4 because there is a plus, isn't it?
Yeah, so so when you distribute the 2 times 2 is 4. And 2 times x is 2x.
Yes, ma'am. Yeah. Oh, yes, ma'am. Thank you.
Sure. Guys, let's remember to mute ourselves as well. Otherwise, this is going to become chaotic. Koklano? Yeah, I hope everyone's muted. Okay, I'm moving on. Guys, remember, there's a lot of us in this lesson, 114.
Hello, ma'am.
Yep. Okay, I'm moving on, guys. Remember, you can ignore me, yeah? What's up? No? Okay. Let's try again. Unmute yourself and ask your question. Okay.
Ma'am.
Let's try again. Unmute yourself and ask a question.
Hi, ma'am.
Yeah.
Hi.
Hi.
Ma'am.
Yes, I can hear you. What's your question?
I wanted to ask that, can we, the improper fractions, the improper fraction, can't we make it to a proper fraction?
No. So remember, improper fractions can't become proper fractions. It can become a mixed number or a decimal, but not a proper fraction. Can't become proper fractions. It can become a mixed number or a decimal, but not a proper fraction.
Okay, ma'am. Thank you.
Vogan, have you got another question, or have you just left your hand up?
Miss,
Yeah.
can I show you like how we do it in our books?
Yeah.
So okay, Miss. Now I'm gonna bring my book, Miss.
Okay, Vogan, try and type it in the chat for me, because we do need to move on. I can't have only done 2 questions in 35 minutes. So type it out for me and I'll have a look. Right, grade 8. So if we now have a look at question 3, here we've got again distribution. So what I want you to do is I want you to remember firstly that you have to distribute. So we need to take this 2 and we need to multiply it to the x and the -4. And we need to take the 3 and multiply to the x and the -2. So I want you to try this one by yourselves. So distribute and then try and solve for x. Remember your inverse operations. Remember when you distribute, you are multiplying. Okay, Vogan, type it out for me because we're carrying on. We're looking at a new question. So try and type it out for me here in the chat so that I can have a look and see how you do it. I'm sure it's fine. Remember, there's lots of ways to do things. So don't stress. I'm sure it's absolutely fine. Bakang, try it. I've told you need to distribute. So start with that and then see if you can go from there.
Let's go, my people. We're doing this by ourselves. We are all trying it, okay? Let's try it, let's try it, let's try it. Bakang, don't worry about it. Do not worry about it.
And guys, don't rush it. Like Yolanda says, try. Start with the distribution. If that's all you can do, that's better than absolutely nothing. But try, because once you've done the distribution, you then can think about, okay, let me get all my x terms to one side and all of my constants to the other side. There should be no hands right now. I'm waiting for answers in the chat and then we will go through it. If you have questions while you're doing it, you type it in the chat and we will help you as you go along. So questions in the chat, guys, no hands right now. Questions in the chat if you are confused, or send Yolanda or myself a message and we will help you. Cecil, I'm not sure then why your hand is raised. If you have something to say, again, you can put it in the chat, but I don't want any hands right now. We're focusing on this question.
Let's go, my people. Let's go. We are 110 of us here, so we should be working, right? Ntiso, I'm happy you don't have any question. And if you do have a question, please put it in there. If we see that it's a question that we need to help you with, we can help you with. Remember, I want to try and answer. Oh, then it's not time yet. So you just have to wait a little bit. And when Teacher Sam is happy to take those hands, she will let us know, right? So as for now, it's not time yet, so you can put that hand down. She will say when she wants someone to actually give an answer, okay?
Right. I'm going to give you another like 30 seconds and then we're moving on. Well, we're going to do this question rather.
Sorry, Nosipo, I think I understand what you're saying and I can definitely remove you. We do not talk to other students is what I am saying, right? Please do not talk to other students because then you will offend them and a whole lot of things. So please, I'm giving you your last warning.
Right, grade 8s, let's have a look at this. So we're distributing. 2 times x is 2x. 2 times -4, -8 is equal to 3 times x is 3x. 3 times -2, -6. And then we've still got that -2 at the end here. We didn't do anything with it. It wasn't being distributed or anything like that, but it is still part of the equation. Now, guys, what I would do is, because I see that this -6 and this -2 are like terms and that I can subtract them, I would do that because what it means is that you're decreasing the number of terms or the number of things you have to work with. And the less we have to deal with, the easier it becomes. So -6 minus 2 is -8. And so I've decreased the number of terms that I have to deal with. Now, if we go back to this question 2, we're going to do something very similar to what we were doing in this first step. The first thing I want to do is I want to take this 3x and I want to bring it over my equal sign, which means it becomes -3x. And the next thing I want to do is I want to take this -8 and I want to bring it over my equal sign. Right, I'm going to try to do this better. Hopefully this won't look like exponents. On the left, I've got 2x. Now remember, I brought that 3x over. So this 3x now becomes -3x when it moves over to the left-hand side. And then on the right, I still have that -8, but I'm bringing the -8 over from the left, so it becomes +8. Add and subtract those like terms because you have to simplify them in order to get x. 2x minus 3x is -1x, or you could just write it -x, that's fine. Now guys, be careful. If we think of a number line, let's hope I've got enough space here. Also remember, you've got a calculator. You can use a calculator. I have no issues with that. I know some schools say no calculators, but use it to check. If you're sitting at -8 and you want to add 8, we need to move up our number line. 1, 2, 3, 4, 5, 6, 7, 8. You end up at 0. So the right-hand side simplifies to 0. And what that actually means, grade 8, is if you want your value or your equation to be equal to 0, and you've got -1 times x equals 0, x has to be equal to 0. If you're not too sure why, well, let's carry on with our inverse operations. Let me just rewrite this because it looks messy. I currently have -1x. I just want x alone. So according to my inverse operations, I'm going to divide both sides by -1 so that I'm left with just x. Now remember, 0 divided by anything, whether it's 1, a million, or a trillion, is still 0. And so x is equal to 0. You can do a check for yourself, and I think this one is worth a quick check because it was quite a tricky one, by substituting in. So if we now sub in our 0, we've got 2 times 0 minus 4 is equal to 3 times 0 minus 2 minus 2. So in the bracket, 0 minus 4 is -4. On the right-hand side, 0 minus 2, -2. So now we do our multiplication. 2 times -4 is -8. 3 times -2 is -6 minus 2. -6 or -6 minus 2, just making my block bigger, gives us -8. And -8 is equal to -8. So x is equal to 0. Right, so my answer here is correct. I've done my check. I've shown that. And we have solved for x. Okay, so I hope I say your name correctly. Cyan, I hope. How did I get -1? So the -1 has come from adding the like terms for x. So 2x minus 3x gives me -1x. I've got 2, I'm taking away 3, -1. I don't think I saw any other questions. So that's how I got -1x. I want +1x, so that's why I had to divide both sides by -1 to get x alone. Maluleka, not too sure where you're asking me how did I get -8. I think you mean right at the start here, this -8. That has come from me saying 2 times -4. A positive times a negative is a -8. I want to then bring that over to the right-hand side. And so when I do that, it becomes +8. So I hope that's what you mean. Liolo, I'm not sure what you mean. Can we get more minutes? Help me out and then I can help.
I think it's just more minutes, as in like more time, because they're looking at the time that the time is approaching. Apparently not really, but you can rewatch the video. We are recording the lesson, my love. That's what we can tell you.
Mamelo, at all times, if we have -8, be +8. So yes, because you have to use the inverse operation. So because this was -8, if I want to take it over the equal sign, it has to become +8. It would be the same as if this was -3. If I'm bringing it over, it becomes +3. If it was +4, when I bring it over, it becomes -4. We're always doing the inverse operations. Lonico, can we do algebraic? I think you mean algebra. I think you're talking about algebraic. This is the algebraic way to solve an equation using inverse operations. So this is how we do it or solve an equation algebraically. Sambiso, that's fine. We get that there's load shedding and stuff. If you need to go, that's fine. Like Yolanda keeps saying, the lessons are recorded. Right, so please take your screenshots. If there are any other questions, you can raise your hand. Hopefully we've got time for one more, but we'll see how we go. So I'm hoping I've answered all the questions. If not, raise your hand. Otherwise, make sure you've got a screenshot. Okay. Mamelo, again, I'm not too sure what you mean. Multiplication inverse, I don't understand what that means. So try and explain it for me. It is the inverse operation. That's how we solve equations algebraically. But yeah, I'll pop a message on the chat and I'll try to help you. Right, let's have a look at this one. I'm going to give you 3 minutes to work this out, to try it. And then I'm going to go through the answers. So again, remember what you need to do is you need to distribute. So we need to go and multiply the 3 to the x and to the -1. And this -2 to the x and to the +2. Give it a try. Like I said, I'm giving you 3 minutes and then I'm going to go through it. And then remember, it is poll day, so you do need to be here for the poll. And remember, guys, even if your working out looks a little bit different to mine, that's fine. Like, Sometimes we do things a little bit differently and we still get the same answer. That's okay. As long as you are mathematically doing the correct thing, it's not the end of the world if your answer doesn't look identical to mine. It might look a bit different. It doesn't have to be identical. But if you are struggling, then it should, because you should be taking down the notes. Remember, you are distributing, and then you're getting all your x's on one side, your constants on another side, and you're solving. Guys, I've just said it's fine if it looks different. It's okay, right? As long as you're getting the same answer, and as long as the maths is correct, it is fine. Okay, please don't stress. I've told you multiple times, it is okay if it looks different. Answers should be the same. Maths should be correct. That is all that matters. Those of you who've already got answers, I suggest substituting or doing your check. Make sure that you agree with your own answer. Right, let's have a look. So we distribute 3 times x, 3x, 3 times -1, -3, minus 2 times x is minus 2x, and -2 times +2 is -4. Now again, guys, you've got like terms on the left-hand side. So just add and subtract them, neaten it up. 3x minus 2x is x, and -3 minus 4 minus 7. Now we want to leave that x alone on the left-hand side. So this -7 needs to come over, and it becomes +7. So we've got x is equal to 10. And by bringing the minus over, it changes its sign to +7. And so what we have here is x is equal to 17. Now again, do your check. You've got 3 times 17 minus 1 minus 2 times 17 plus 2, and that should all equal 10. 17 minus 1 is 16, so we've got 3 times 16. 17 plus 2 is 19, so we've got minus 2 times 19. If you now go and multiply, 3 times 16 gives you 48. -2 times 19 gives you 38. So we've got minus 38. 48 minus 38 is 10. Left is equal to right. X equals 17 is correct. Right, so distribute. Get all x's to one side. Use your inverse operations.